Hey there, welcome to another college algebra video. As exciting as these are, we will be spending a little bit more time in chapter 2 today, section 2.6, combinations of functions, focusing mainly on the composite functions, composition as an operator. You can add, subtract, multiply, and divide numbers, and you can do the same with functions, but you can compose functions, which is a fifth operation that you can do on functions that you can't do with numbers. So it's a little bit more complex, but we'll talk about it here. Okay, so today we're going to go through the domain of a function, a little refresher there for us, at least in this course, all right, how you can find the domain for our class. Combining functions, doing the algebra of functions, finding composite functions, and dealing with the domains for those new functions as well. Okay, so remember that when you're finding a domain, if it does not model data or verbal stuff, if it's not a model, if it's just a function, f of x, blah, 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 then the domain is the largest set of real numbers for which any value of f of x is defined as a real number. So for example, if you have an even root, right, like a square root, you can't have a negative number. If you have a fraction, you can't divide by 0, right? So stuff like that's what we're talking about. And those are really the only two times that we're going to have to worry about this. So if we have a fraction, right, we set the denominator, set the bottom equal to 0, and that's what we don't want. That, and if you have a square root or another even root, okay, if that's what you have, then you set the stuff under the square root greater than or equal to 0, solve, and that is what you do want. Okay, so let's do an example here. If you've got the function g of x equals 5x over x squared minus 49, you do not want x squared minus 49 to be 0. So you set it equal to 0, take the 49 on the other side, square root both sides, plus or minus, and you get plus or minus 7, right? So remember, this is a fraction. This is what you don't want. I don't want plus or minus 7. So how do I write that? Okay. I'm going to say that we need to exclude 7 and negative 7 from the domain, and so as a set of intervals, it's negative infinity to negative 7, not including the negative 7, between negative 7 and 7, and then above 7. Another way that I am okay with you writing this, but I don't know that my math lab will accept it, but if you're writing it for me, you can just say x is not equal to plus or minus 7, because if you say x is not equal to plus or minus 7, that tells me it could be equal to anything else, real numbers. Okay, so that's okay by me. All right, so that's just a little reminder. If you need more work on domains of functions, you need to go back to the beginning of the chapter. So algebra of functions just means being able to add or subtract or multiply or divide functions. And when you add or subtract, multiply, divide, you do exactly what it sounds like. When you're adding two functions, you add the first one plus the second. When you're multiplying two functions, you multiply the first one times the second, etc. All right. The only thing you got to worry about is if you're dividing, g of x obviously can't be 0. So you have to take that into consideration. And then when you go to find the domains of these guys, you just take the domain of f and the domain of g and intersect them. All right, take the overlap of those two things. Okay. So for example, if f of x is x minus 5 and g of x is x squared minus 1, then if you want to add them together, what do? You just take f plus g. Literally, you just take those two together, f plus g, x minus 5 plus x squared minus 1, and then you combine like terms, x squared plus x minus 6. How do you find the domain? Well, for this problem, it doesn't really do much because x minus 5, linear function, all real numbers is the domain. X squared minus 1, that's a parabolic function, that's a quadratic function, and again, it's a polynomial, so the domain's all real numbers. So when you take a look at the domain of f has no restrictions, the domain of g has no restrictions, so the domain of the sum, f plus g, is all real numbers because there's no problems. Right? If there were problems, then you'd have to leave those out of the final domain. All right. But I think you'll see it better probably when we get into composition of functions anyway. So we're just going to jump ahead there. If you need more practice on combining functions, obviously there's homework and practice problems for you to do. But we're going to focus on the fifth operation, and that is a composition of functions. So composition of two functions means that you take one function and you actually put it inside of another function. That's why you can't do this with numbers. You can't take a 3 and stick it inside of a 2. You can multiply it by 2, you can divide it by 2, but you can't take 3 and shove it somehow into 2. That doesn't make any sense. But functions, because they get evaluated at different places, you can evaluate them at a point G can be evaluated in an X, and then that new value can also be evaluated in the F, okay? And so if you want to find the domain, then we'll talk about that in a minute, but if we want to find the domain is all of the X's that are in the inside function, and then you need G of X to be in the outside function's domain. So there's an easier way to go about this. We'll talk about the domain in a minute. So let's just focus right now on the composition of F with G, okay? We use this little circle to represent what we're doing. This is not an O. Some students call this fog, and if you write it the other direction, right, they call it golf. That's not the way that you really denote it. What we say is we're saying G of F of X. If you want to think of that little circle as anything, you can think of it as an O for of, G of F of X, okay? F is done first, then G. In this case, G is done first and then F. Okay, so let's look at an example. Let's find F of G of X. Okay, F of G of X. So that's what we're going to find. Now, be careful. Remember how we do this. F is thought of as the function 5 times something plus 6. And whatever goes in here goes right there. These are blank spaces, right? So what we're going to do is we're going to have F of, and I'm going to write it in blue, G of X. Well, what is G of X? G of X was given right here to be 2x squared minus x minus 1. So all of that is G of X, and that's all supposed to go inside of the F function. So the F function is 5 times stuff plus 6. And so if we put that in the F function, we get 2x squared minus x minus 1. So this right here, this step right here is the actual composition happening. All right, we have composed F and G. All right, G inside of F. And so we've composed those. Here you see the function inside of the other function. But now there's algebra to do, and so to do the algebra, we distribute and keep going. But everything we do underneath this blue line, this is just basic algebra stuff that you guys should be comfortable with doing. All right, and so we get F of G of X. And if we simplify this, we get 10x squared minus 5x plus 1. And that is the new function that is from F of G of X. That's the new function. Okay? That's how you do it. So I'm going to ask you guys to take a look at the other direction, because it turns out that composition is not commutative. What that means is the order matters. There's a difference between F composed with G and G composed with F. So I want you guys to take these same two functions, but I want you to do G composed with F. Notice there are two X's this time to plug into. Remember how this works? G composed with F is G of F. And G is what? G is 2 times stuff minus 1. Okay? So you guys pause the video, take a minute, finish this out, see what you get. I want you to do it all the way though. You got to square it out and everything. Okay? So plug it in properly and then do the algebra and come back and let's see what happens. Okay? So what is F of X? F of X is 5x plus 6, which means that goes in here, 5x plus 6, because that was where the x was, and there was another x here, 5x plus 6, so we plug them both in. So this right here, that is the new stuff. Okay, that is your composite function. But we haven't simplified it yet. We need to simplify, and remember when we do that, that we have to use your Dear Aunt Sally rules, which means exponents come first. So this is going to be 5x plus 6 times 5x plus 6. Don't distribute the 2, but FOIL this guy out first. Okay? Distribute the negative sign, you get 5x minus 6 minus 1. Let's FOIL this out. We get 2 times 25x squared plus 30x plus another 30x plus 36 minus 5x minus 7, negative 6 minus 1. Okay? And then we get 50x squared plus, this is 60x together, times 2 is 120x. 2 times 36 is 72 minus 5x minus 7, and then we combine like terms. So g composed with f of x is 50x squared plus 115x plus 65. Okay? So that is your new function. Again, nothing fancy there, but everything below the blue line, all this stuff, if you had trouble down here, this is trouble with algebra, basic algebra. So if you need help with this, this is actually chapter P stuff. So if you need help with this, please let me know and I'm happy to help you. But this is the 2.6 concept of composition. Okay? So once you have composition down, we have to well, we have to look into the domain, right? So if we're looking at f of g of x, remember that's f circle g, that's the way we write it. Then if you want to find the domain, then these are the rules. But the way you really end up doing it is you find the domain of g, the inside guy, okay, function, and then you find the domain of the final function. And then you put them together. These two go together. Okay, so let me show you what I mean by that. Here's f of x equal to here's f of x equal to 4 over x plus 2. Here's g of x equal to 1 over x. And so we're going to combine those. F of g of x, how's that work? Well, what's f? F of stuff is 4 over the stuff plus 2. And g of x, that means g of x goes down here. What is g? G is 1 over x. So we plug in a fraction inside of our fraction. Okay, 1 over x goes here. And then if we clear the fractions, you can also do complex fractions by finding a lowest common denominator in the bottom. If you need to take extra steps, that's great. Distribute the x. What happens? On top, we get 4x. On the bottom, x times 1 over x becomes 1. But then that x is still there to multiply by 2, and so you get 1 plus 2 over x. So f of g of x is 4x over 1 plus 2x. So that's our domain. That's our composite function. How do we find the domain? 2 steps. First, what was g's domain? Because it was inside. Well, g was 1 over x. That means x cannot be 0. If you set the bottom equal to 0, you get x can't be 0, right? Then number 2 is the final function, f of g of x. And there you've got 1 plus 2x cannot be 0, denominator. Solve for x, and you get x cannot be negative a half. Subtract 1 from both sides, and then divide both sides by 2. All right? So the actual domain then is what? X not equal to 0 and negative 1/2. That's the final answer. Both of these numbers have to be included. 0 causes a problem at the beginning, and negative 1/2 causes a problem at the end. Okay? And that's all you do. That's how you find it. So y'all check out this now. how do we think of this backwards? We want to think of h of x as two functions. What are the two functions here? There's a square root function and there's an x squared plus 5 function. Those are the two functions. Which one's inside? Inside function is x squared plus 5. The outside function, f of stuff, is the square root, and since we just need something to hold the place, we put an x there. And so h of x is equal to f of g of x. You can check yourself, right? F of g of x would be f of x squared plus 5, which is square root of x squared plus 5, right? So that kind of checks it there. So if you let g be x squared plus 5 and f be square root of x, then that tells you how to build the function h of x. Okay, so that skill is important to be able to handle more complex things down the road. All right, but for right now, the most important thing for you to be able to do is to be able to figure out the composition, do the algebra to get there, okay, and then calculate the domain from it. Okay, hope that helps. Do a lot of practice, lots and lots of practice on 2.6, and we'll see you later. Thanks.